And I'm quite big on software engineering fundamentals and concepts. So more about the why instead of the how. Those are things that get me excited. That's why when I saw Brian Getz write an article about 2 years ago now about data-oriented programming coming to Java. So I was quite excited because I had no clue what data-oriented programming actually meant. So I wanted to figure that out. And I went searching online and I found quite a few talks. And most mentioned these new language features, records, sealed classes, and pattern matching, which ends off because these are the things that should make this data-oriented programming possible. However, basically all talks I found were about how to use these new language features. And that's why I don't want that to be the main focus of this talk, because I needed answers to the question, so what actually is data-oriented programming? And because I couldn't find the answer of that talk online, then I figured, oh, for the question online, I figured then I'll just write my own talk about it. So although we'll go into a few language features at the end, and that's not the main purpose of this talk. And something that's important to me, that this is not a better way of programming. It's a different way of programming. There's a lot of debate between functional programming and object-oriented programming and such. And for me, especially as someone who's more into fundamentals, in the end, it's all engineering. And both ways have trade-offs. Some work better in certain areas, other things will work better in other areas. So this is not a better way of programming. It's a slightly different way of programming, and one which you might already do. Brian Getz has a really good talk, Functional Programming, Object-Oriented Programming, Pick 2. And he ended with this quote, don't be a functional programmer, don't be an object-oriented programmer, be a better programmer. And I think this for me, this was quite inspiring, as in, no, we shouldn't be dogmatic. We should get as many tools in our toolbox as possible, so we are prepared for every situation and we can write the best possible solution for every occasion. So what are we going to talk about today? We're going to do a quick recap about object-oriented programming, functional programming, data-oriented programming, what it actually means. Then we'll head into the data-oriented programming mindset, programmer mindset. We'll take things to a bit of an extreme there, but it's just to get a picture of what it's like to see data as data. Then we'll go into what data-oriented programming does to our architecture and how we can use it there to make our application more scalable. And then we finish off with talking a bit about what the language feature actually means, a new language feature actually means and what that allows us to do. So let's talk with object-oriented programming versus functional programming versus data-oriented programming. So what's object-oriented programming? Well, here everything is an object, and it uses encapsulation to create boundaries within your application. And it relies heavily on the tell, don't ask principle. So what do I mean with that? It means if we would have some code like this, where we have a car with current fuel and a max fuel and some getters and setters, if you would have a function add fuel that takes a car's input, here we ask the car for the current fuel and we ask the car for the max fuel. And then we set the current fuel. This is not really the object-oriented programming mindset, because here we ask the object for its data. Instead, in object-oriented programming, we want to tell the object what to do. We want to tell the car to add the fuel and just give the amount. And how it solves it, we don't care. We just tell it what to do. We don't care about the data, we care about the methods. Put that more in perspective, if we would have a class data, we actually don't really care about what fields it has. We care about what are things we can do with this car object. If you then look at functional programming, here everything is a function. A good way to symbolize that, and they're tied together using something called composition. A good way to visualize that are dominoes, where every stone could be seen as a function, which has a number as input and a number as output. And as long as the number output matches the input of another stone, you can chain them together. And you can create really beautiful software that way. That's the basic premise of functional programming. So what is data-oriented programming? Well, here everything is data, or more specific, everything is about the data. So if you would have any class within data-oriented programming, we don't actually care it's in a class. We just care about these two fields because that's the actual data. It just happens to have something called a car wrapped around it, but we don't care about that stuff. We care about what's inside the car. Is the data we can work with? And this brings us to the data-oriented programming mindset. So here, data-oriented programming mindset, it's all about the data. To visualize that bit, if you take a big enough step back, and look at applications in a really abstract way, most applications are just data streams, and data streams are nothing more than data transformation. So data streams is nothing more that you have a source, which is something that emits data, and a sink, something that receives data. And the nice thing is there are only basically 3 operations you can perform here. There's a filter that takes data away from a stream. There's a map that changes data to another type of data. And we have a branch that either says, splits up the data in one way, another way, or just splits it up evenly. And using this way of thinking, you can actually model basically every application out there. To give an example, if we would just look at any web service, we would have some JSON that gets mapped to the user. A user might need to go, we might need to check some permissions, which is a filter operation because everything might stop there. Then we might try to filter the user out because it doesn't come through our validation phase. And once everything is done, we map the user to a query, we map the query to an entity, and we map the entity to a response, and we map the response back to JSON. So if you look at any application abstractly enough, it's just a data stream that goes from JSON through this back to JSON, using only map and filter operations. So there's also a lot of state changes going on here. We go from user to query, from query to entity, from entity to response, and response to JSON. And usually in Java, we use types for this. So we go from JSON to hash map, from hash map to user, from user to entity, from entity to response, from response to hash map, and from hash map back to JSON. And that's quite a lot of types for quite a simple operation. And this is where a real data-oriented programmer thinks, that's not very good. Because types also have a downside. And types don't naturally map well to other types. So if you want one type to map to another type, you usually have to write a custom mapper. So if you make a class person and want to turn it into a second person, you would need to write a custom mapper. Or you have to use reflection. For example, Spring Boot uses Jackson as Jackson for JSON serialization, which uses reflection under the hood. Working with types either means you have to write custom code to map one type to the other, or you have to rely on reflection magic to do it. So types don't map well to other types. And this is a problem, according to data-oriented programmers, because that's most of the things we do. We map types to other types. So types don't naturally map to other types. So data-oriented programmers are like, why shouldn't we use data structures that are made to do these things, like hash map or lists? These are data structures that are meant to do operations such as map and filter and such on the data structure itself. So if we would instead of that use hash maps, it would look something like JSON to hash map to hash map to hash map to hash map to JSON, which is a lot easier in a way. We don't have to write classes for intermediate data representations. We can just go from JSON to a hash map, then it's hash map all the way back to JSON. So that's basically thinking in it's just data. We don't care about the types. We only care about data and data transformation. So does this mean that we should just stop using types? Well, not really. Like real data-oriented programming languages like Clojure, they can get away with this. Because in Clojure, you have things like schemas where you can basically tell that the hash map should have at least these keys. And they circumvent certain problems by just writing a lot of tests. And this is where types shine, because types gives a lot of compile time checks. And therefore, we have to write a lot less tests because we are certain these fields are there because we use the type system. So in Java, I wouldn't recommend going all hash maps, but we can learn something from this way of thinking. We don't have to model our data in that structured way. We can also denormalize data, and that can have some benefits as well. To give an example of that, if we have a public class person, which has an age and a name, if we would have a bunch of persons, we could put them in a list. And this is nice and ordered. We have a person and we have a list of persons. A way to denormalize this data would be our class persons, which contains two lists, one containing the ages and the other containing the names. So these are two ways to represent exactly the same data, where this is nice and structured, and this, well, I don't really like, you would normally really like this representation, but it can have some benefits. And that really shows when you look at, for example, databases, where if you make a database for your own software or a database designed for your own software, you want everything to more look like this. Everything should be normalized. There shouldn't be duplication. Everything should be nicely checked with foreign keys and everything. So the database can protect you against mistakes and protect you against data corruption. But it has a downside, is that the queries are relatively slower than they could have been. And so if you would give your database to a data warehouse, they would do really, really bad things to that data. As in, they would duplicate everything, create massive tables, but they're all optimized to do certain searches, which are lightning fast. So by giving up all the structure and all the deduplication as such, we get a lot of performance. And this is also what we can do in code. Instead of having nicely structured code, which is optimized for longer term maintainability, we can also go for different representations of the same data and have it to be lightning fast. Where you see this a lot is the gaming industry, for example, because in the gaming industry, you want that 60 FPS. So doing every trick in the book to make sure you get to that, that's important there. There is also a bit of a different distinction where the trade-off of long maintainable code versus quick code tends to lean more towards quick code with gaming, because even though the statement isn't that true these days, but once the game is finished, you don't really do more patches on it. While enterprise software will get a lot of maintenance over the years. So the trade-off of, we rather have fast code than code we have to maintain. In gaming, that leads more towards the fast code, while enterprise software would lean more towards structured code. But if you have a struggle somewhere with performance, well, these are tricks that you can do. So that's the reason why data-oriented programming is very popular within within the gaming industry. So aside from performance, data-oriented programming also affects the architecture. So let's see how we would design something in object-oriented programming versus the data-oriented programming way. In object-oriented programming, all the use cases live together with the data. As we saw, we have this tell, don't ask principle, where our car would have a method set view. And this makes it very easy to see what operations are available on that data. In data-oriented programming, we don't care about the class. We only care about the data. And therefore, use cases will live separate in separate components. And so they won't be directly connected to that data, which does give a cleaner object graph and can scale better. To give an example of that, let's implement the save method in an object-oriented programming tell, don't ask way. So we tell a person it needs to persist itself. Well, in order to do some persisting, we would need something like a data access helper. And there are three ways to do this. One is that a person would get a data access helper for its constructor. So when calling the save method, it can use that data access helper. The problem here, however, is now construction of the person becomes way more difficult. Aside from all the data, you also need to give all the dependencies for all the side effects that the person needs. We could, of course, cheat this and use a static lookup instead, which would work, but now it's very, very difficult to mock this, which is also not very good. So this makes it a lot more difficult to test. Or finally, we could try a more visitor pattern approach, where we would pass the data access helper to the save function. But now both the caller of this function and the person needs to know about how this object should be persisted, which is also not good. But the bigger problem here is that all three methods rely on the person class to have knowledge of the data access helper. So if you would put this into a diagram, a person would now be dependent on the data access helper, and new component would be dependent on the person. But because person has this dependency, transitively the component is also dependent on the data access helper. And if it's just this, then it's probably fine. But what if we need to add a second component, which needs to do something with a person that involves a REST controller? Then our object graph would look something like this. The first component needs to do the person to do something with the data access helper. The second component needs the person to do something with the REST helper. But now, transitively, both components are dependent on both the data access helper and the REST helper. So we started creating a bit more of a net here. Also, what if we don't need this component anymore? This use case doesn't exist anymore. We will remove this. Will we actually also remember to remove all the code within person that was needed for just that use case? Because you probably wrote tests for this, I assume, and therefore the IDE won't show you those methods are no longer in use. So since the person class slowly will get bigger and bigger, at some point, it's quite likely you forget to remove these methods, which means that it will have become even bigger than it should be. So there's a bit of risk in there as well. Like I said, the chances of applications shrinking are not that big. Most applications only tend to grow. So the amount of use cases will increase. And therefore, our object-oriented classes will increase as well. We just keep adding more use cases to, for example, the person class. And I've seen this happening. I worked at a company where we had a bit of software that was already in development for 15 years. And we had this exact problem that a few of our core components were getting massive with all the use cases it had to support. So how can we solve this using data-oriented programming? In data programming, again, we don't want to mix the use cases together with the data. So the only thing we can do is we create a component for every use case, and then we pass the data as arguments to that component. So that would look something like this, where we'd have a person persister, which would take the person as data and then just save that person. So the person doesn't know that it's being saved. That's just a bit of data. This use case decides to save the data using a data access helper. And if you would look at how that would look within our dependency graph, it would now look something like this, where the component that needs data access helper is dependent on data access helper, and it's dependent on person. But person doesn't know it's being used by the data access helper. So what happens in this case when we add a second component which needs that REST helper? Now it would look something like this, where this component only knows the data access helper and a person, and this component will only know the REST helper and this person. And the person doesn't know anything. So our object graph is way, way cleaner this way. So what if we remove a use case? Well, now we can just remove that component. And all the logic containing to the use case has now been deleted. Of course, we could still forget to delete the whole REST helper thing, but at least this doesn't harm things in any way. This is just a separate bit of code that doesn't get called anymore. But it's not part of your big monster OO class anymore. So the worst case scenario, this isn't that bad and can even be reused at a later point. And if you now think this kind of looks familiar, well, if you write a Spring Boot application, for example, this is kind of what you already do. You take some data, you pass it, for example, to a service, and the service will persist that data. So you don't build a save method on that data on the data that you pass to the service. You do that within the service. And for me, that was quite a revelation that I've actually been doing data-oriented programming for years and years now. I just didn't know that this was being called data-oriented programming and wasn't actually object-oriented programming. So if you use any frameworks like Spring, Micronaut, or Quarkus or something, you probably already do things in a data-oriented programming style, which I found to be quite interesting. And it also shows that, oh, it actually works. So should you not use object-oriented programming anymore? No, not really. That again, it's just a tool in your toolbox. Just be a bit careful with how your dependency tree will turn out to be, and therefore where you put your business logic. But most importantly, be pragmatic and not dogmatic. Do whatever works best for your application, and it might even be a combination of the two. And that brings us to the final bit of my talk. How can we use these things in Java? And like I said, I don't really go that much into the language features itself, but I'll try to show the idea behind using those language features. Because the biggest part we have that all these things added is a new way to use polymorphism within Java. Polymorphism is basically if one object extends another thing, now it's both types. Therefore, it's polymorphism. So polymorphism is just a fancy word for if one type extends another type. And for a long time in Java, this was mostly used to share code. But right now, with the new Java 21 language features, we can also have a lot of benefits for just sharing types. An example of this is using the strategy pattern. First, in an object-oriented programming way, and then we'll see how we can build the same strategy pattern now in a data-oriented programming way. So the strategy in object-oriented programming means you have an interface, for example, credit card, which has a method pay. We can have two implementations of this credit card, a Visa card and a MasterCard, and both have a dependency on the actual thing that's the side effect that does the payment. So Visa card has a dependency on Visa card payment, and the MasterCard has a dependency on MasterCard payment. And a component only knows the use case component only knows the interface. So to put that into code, we have one interface credit card, which a method pay. A MasterCard implements a method pay in its own way, and a Visa card implements a method pay in its own way. And now the logic component gets any credit card. It doesn't know which one, but it does know it can just call the pay method. And the really nice thing about the strategy pattern that it's fully compile time safe. If I would ever add a third credit card, the interface forces it to implement the payment method. So the logic will work on any credit card I would ever add into my system, fully compile time safe. So my compiler can really help me here. So this way, it scales really well because I don't have to change basically any code if I add another credit card. However, it does force us to have our payment methods together with our data. So let's see how we could do the same in data-oriented programming. So what we kind of want to create here is we still have an interface credit card, which is either a Visa card or a MasterCard, but we want to remove all the logic towards a component. So now the component should know the Visa card payment and the MasterCard payment. So to do this, we can use Java's new records, where we create the interface credit card. And since we don't actually need any methods whatsoever, we can just use a record because it only holds data. So it only holds the credit card number. So it creates a record for Visa card and a record for MasterCard. And this is where Java 21's switch statement comes in. So we can now pattern match over the credit card and do an instance of check. So in case it's an instance of MasterCard, we put it in the variable MC, and then we call the MasterCard payment component to do the payment. If it's an instance of Visa card, we put it into this variable, and we can tell the Visa card payment to do this. And for a very, very long time, this was the reason why we don't really use this pattern a lot in Java, because we have to have a default statement here. What if another credit cards get added? Then we will automatically go into the default mode. And this is why we lose all the compile time safety that we had with the previous strategy pattern. Because if I add another credit card, I will get an illegal state exception here. Well, with the previous pattern, if I would add in object-oriented programming, if I would add a credit card there, it would always work. To overcome this, Java introduced the sealed keyword. So we create a sealed interface credit card, which permits Visa card and MasterCard. So basically we tell the compiler here, the only two possible implementations of this credit card is either a MasterCard or a Visa card. And there are no other implementations. And because we told the compiler this information, if we pattern match over a sealed interface, we now get this. We don't need the default anymore. Since the compiler knows these are the only two possible implementations, it will even auto, like if you use IntelliJ or something, it will even with Alt Enter complete the whole pattern match for you, because it knows which are all the possible implementations of the credit card. And if you would ever add a credit card in the future or remove one, this switch statement no longer compiles. So finally, we have our compile time safety back again. So we can actually use this pattern. So until Java 21, we didn't really have the option to do this. But during Java 21, what we actually finally created was our branching operation. because that's what we're doing here. Given a credit card, we either go one route or we go another route. And this is really, really good, since we can not just use this for credit cards. Also think, for example, oh, we get a contract. If it's a signed contract, go this way. If it's an unsigned contract, go that way. We get a result from a function. It either succeeded or it failed. We can use this pattern matching for all kinds of purposes. And that's why I think this is really a game changer. This is a new way of using polymorphism we didn't have access to until before Java 21, which also means it will, I think, take a while before we get used to this, because this is a feature that has been in, for example, Scala a lot for a very, very long time. And it's also there in Kotlin. But in Scala, basically, people don't write if statements anymore. Basically, everything is done through sealed classes and pattern matching to predict or to do all the flows. And this also really helps you in thinking in state changes. So like I said in the beginning, when you think about an application, it's mostly data transformation, which is just state changes. For example, like I said, a contract, if it's signed, do this. If it's unsigned, do that. So with Java 21, we actually have a whole new way of using polymorphism. And if you find it interesting, I can tell a little bit more about that after I finish the talk. But in conclusion of data-oriented programming in Java, is most applications are just data streams if you look at them in a very abstract way. And data streams only have a map and a filter and a branch operation. And it's basically just state changes through data. So why have types? You could use hash maps as well. And this can be beneficial for performance increases. By separating state from functionality, we can offer some better scaling, because we can create components for every use case instead of all the use cases having to live inside a single component. And thanks to the new pattern matching with instance of and sealed classes, we now have a game changer with compile time safe branch operations. And with that, I would still like to end with a slightly adjusted quote from Brian Getz. Don't be a functional programmer, don't be an object-oriented programmer, don't be a data-oriented programmer, be a better programmer. Don't just write hash maps everywhere right now. All these things, all these ways of thinking and using, they're just tools in your toolbox. And most often, it's a combination of all three. That's what we get the best out of your software. And with that, that's the official talk. If you have any questions, we can go into those now. I can also tell a little bit more about what kind of big deal the new pattern matching thing is, if you guys like. If you have any questions later, you can add me on Twitter or X, as it's been called now, or LinkedIn. I'm actually a bit more active on LinkedIn. I also have a website if you want to see any slides of me, of all my talks, or any recorded talks. They will all come on this website. So this talk has been recorded on HeatCon before, so that's also a way to look it back. I do want to give some attention to this. This is a website I'm also a member of. It's a place where people can either offer to mentor others voluntarily, or you can look for a mentor. So everything is voluntarily, no cost to any party. And I already helped like 5 or 6 people there. And it's just a really rewarding feeling if you can help someone. So if you have any skills and think you can help, if you can help someone else, please register as a mentor. Otherwise, if you're looking for a mentor, you can go to that website as well. Like I said, I'm quite big on knowledge sharing. And I would like to have this kind of knowledge accessible to as many possible people. And most of the skills I possess now almost all come through teaching others. So it's a really good investment, not only in others, but also in yourself. And if you just want to see the sheets, you can find these on this URL. So with that, are there any questions?
Satish Kumar here. I think there are a couple of questions. Raja has a question. So before that, I will go with mine. Considering that this data-oriented programming can work with the latest version of Java, that is only when we use sealed classes and record, which is a recent addition. And how do you see the adoption of these features? Because the community itself is lagging, right? Most people are there in 11 only. So for an existing programmer in your team, did you find any problems, or how is it actually the adoption?
The thing is that, well, first of all, for any paradigm, you actually don't need that many language features. It's like just with functional programming, like Java can do functional programming very, very well. You don't need a Scala to do that. It's more of a way of thinking and applying those patterns. And of course, some languages do things more easily than others. Like without sealed classes, this stuff becomes a bit harder to do. And the thing is that I think it will, using this sealed classes pattern matching, I think it will take a long time before we actually start using it, because people don't know this way of thinking. Because, well, we can go a little bit into theory, because up until then, this is a completely new thing in Java. We have something called type theory, where you think about types. And we have this very fancy word called an ADT, which stands for algebraic data type, which is just a fancy word for an immutable object. And you have two different immutable objects, two different kinds of algebraic data types. We have product types and we have sum types. Product types are just like if you would make any immutable class, you would probably make a product type. So what do we mean by that? A person is, for example, has a name and an age. So if you want to create all possible persons, you have to do all possible names times all possible ages. So it's a product of all names and all ages. So this is a product type. A different way to see that is this is an AND type. A person is a name and an age. A sum type is an OR type. OR type is, for the only thing we had in Java was an enum. For example, it's Monday or Tuesday, and it can't be either of them. So it's this one or this one. This is what we call a sum type. Thanks to sealed classes, we can finally have other sum types instead of enums in Java, which means that, for example, the Java optional could now be re-implemented as a sealed type using none and sum as which now, if you return an optional, it's either an instance of none or it's an instance of sum containing something, which allows you to do the whole branching pattern matching over it. So this is, for example, how language like Scala does this kind of stuff. Yeah, sorry, I just read the chat. This is, for example, how languages like Scala do it all the time. But this feature has been in Scala from the start. So they had years and years of experience in this way of thinking. In Java 20, we just had this, that Java is, what's 25 years old now or something. We never had this before. So we have this whole legacy of thinking, not in this way of thinking. So now we finally get to that point. So I think it's going to be a while before we adapted our way of thinking to see how powerful this way of working can be.
Yes. And just curious, maybe my question may be a stupid question. So can you tell me the use cases where you can see some immediate benefit? For example, is this relevant to our ORM related items where we interact with the databases? Do you see data oriented programming will have an impact on these core fundamental areas in enterprise application?
In what kind of in the enterprise application?
Object relational mapping, database, JDBC interactions, and all those stuff, where we do a lot of data transformation.
In practice, I don't think so. I see this way more as the control flow of your software can be quite different. In practice, I don't see all the reflection being changed, going to hash maps and such. And this stuff doesn't really help a lot with object relational mapping. So in practice, in most enterprise software, I don't think people will use it in that way. However, using some types and using that for control flow, like using the branch operation based on type, I think that's going to be a thing. I already started using that in some applications, and people who didn't know the concepts didn't actually need that much explanation to see, oh, this is actually quite useful. Also in practice, it's very easy to do, since most interfaces in most case, or most even class or interfaces that you create can become sealed. It doesn't have any downside of making them sealed. Since you're not really using the like if you have a library, you can even use it to add compile time safety, because you can normally you have to make classes final and such to prevent others to extend it. Now with sealed, you have a different way to prevent people from extending from it. So I'm thinking out loud, so it might not be completely organized. All right, so I see, can we add annotations to parameters of a record class? Oh yeah, that works. If you have a record, that just works. I just saw this question. We can name the method to say visa pay in the data owner approach. That would break, the pay comes from the interface, so that would break the interface. So I don't really fully understand the question.
Yeah, can you show me that slide where you had a switch case?
Yeah.
Okay. Yeah, you're saying credit card is still an interface. Then why should I even put a case and then call mastercard.pay? I can directly call credit card.pay, right?
Yeah. Why you put it in a separate variable?
Yeah, instead of two switch cases.
Yeah. Yeah. Well,
if I'm depending only on the credit card interface.
Yeah. In this case, Mastercard Visa don't have any. As in you don't have any methods by itself. So right now, this is doing all the logic, and this takes only a Mastercard, that's why we need to do pattern matching on instance of.
So, which means, the question I asked, I can name this Visa card in the different method name.
Which method are you referring to now?
The second case.
You mean this thing?
Exactly. I can.
But this is okay. Then I said this is just a dependency of the component that calls this. Right now it's a static call. So this is something different from this. This could be called Visa Pay if you like, but for this example, it wouldn't make a difference.
Because anyway, credit card is just a record. It is
this is just a record, and this is just data that's being passed to. Basically, this is in case it's a MasterCard, I want you to do this with a MasterCard. If it's a Visa card, I want you to do that with a Visa card.
Thijs, I have one question on this, right? So, given that record is more open, we will be using mostly in the data classes which are more open immutable in nature, right? Mostly records are immutable. Now, given that we also have something called as a builder, where we also try to do some immutable classes there as well with the state. What you state, we define the builder and we just pass on the different attributes that will become my one's object. I can't modify. So with the builder as well, we try to achieve the immutability there. Although it gives a better fluent way of building the objects with the optional attributes, but ultimately it provides me the immutable objects, right?
Yeah.
Now I have the debate on these two things. Now, whether you should go with the record classes in that case or whether to go with the builder classes on the entities.
Yeah, this is all hints on immutability, and Java is not good in immutability right now. One thing that Lombok does add, it has indeed an add builder annotation. I personally don't like builders because that's in a lot of cases it's a missing language feature, since builders allow you to build an object without passing all the properties it needs to pass, and then it will fail at runtime, which means if you call a constructor, if you would add something to that constructor, you now get a compilation time check that this is not going to work, or these are the places where you need to fix something. By using a builder, you lose that compile time safety. So that's the bit what I don't like about builders. That being said, Lombok's builder has something where you can take an existing object, call a toBuilder method on it, and then you can set one property to be different and then call build again. That would work. But in Java, we will get a better way to do this in a newer version of Java. And basically change only one property of an existing object if it's a record. So this way, we do get around a bit about a bit of quality of life features regarding immutable objects. So this stuff like this is coming in Java.
Okay.
Does that help a bit in answering your question?
A bit of help there, yeah. I had one debate yesterday, I mean, with my one of the senior person, and his thought also was valid. I just want to get your opinion on one of the questions that we've been discussing. In predominantly, if you look at the past, now if you look at the data-oriented program as well, where we define a data model, we define some attributes, and then we say, okay, at the rate getter, at the rate setter, we define the getter setter, and whenever I need that object, I just use the get method or get attribute and then set attribute, right? Now,
Yeah.
if you think of the data-oriented programming, we generally used to have this setter method, getter method, where you want to have some control over my attribute that I'm going to set from externally to model, where you can write some business logic to validate some of the values that I'm passing it, right? That was a intentional in the past. Nowadays, it's more about just transferring the object one state to another state, one object to another object. It's just setting up those some attributes, right? And rather than having this setter and getter methods itself, why not to have a right object dot the attribute name is equal to something, some different value, rather than using setter method? Because nowadays it's just the data transformation is just only holding the objects for temporary my purpose, and then I'm transforming to a different state with a different model altogether, right? So he has the thought that, okay, if you're not writing any business logic, it's just a data model that I have. He likes to write, okay, the object dot attribute name is equal to something, and it gives them more readability as well in terms of it. And I know that there's not going to hold any business logic. It's just as a value I'm going to set and just passing along the my different functionality or different use cases. So yeah, so I just want to understand your thought on this model or paradigm. That's what I'm trying to say.
Now,
so you say p dot set name, he doesn't like it.
But he rather does
but
this.
He like this way.
Yeah, I don't like mutable state. Since it's almost 5. The thing what I hate about mutable state, if our car here was a mutable car, and we have this bit of software where I print out the car, I pass the car to my paint method, and then I print out the car again. Do these two things print out the same color? We don't know. We don't know if the car is mutable. We don't know if this method changes or not. So the only way to know is go into this method, hopefully see it there, and hope that method doesn't call another method with the car and such. As in, we need to know quite a bit of our software in order to know if these two things print out the same thing. If we, however, would create an immutable car, and now ask the same question, do these two statements print out the same thing? The answer must be yes, because the car is immutable.
Correct.
So this is where immutable objects really reduce the cognitive load of software engineering, because I can instantly say things about this code that has to be true, and I don't have to read everything that this does. The downside is, yeah, if you want to change values, you have to create a new instance, but it means you have to return something. What happens now is, if you now ask a question, do these two things print out the same thing? Probably not, because you can see the state change going on here, because it needs to be a return value of this function. Therefore, or you can either instantly tell nothing changed, or you can immediately tell something must have changed. And this is what I really like about reducing cognitive load by using immutability. Because if things are mutable, yeah, you don't know where in the software variables can get set, which means you can't rely on it, which means you have to be in control of your entire program. While here, I can instantly see, I probably need to maybe check some things after this, or at least see a state change has taken place. So I don't like mutable state. It has some benefits in terms of performance, but if you're gonna do mutable state for performance sake, I kind of like my functions to have an immutable state in and an immutable object out, and only all the mutable state is within function scope. This way, the mutable state doesn't escape this function, and therefore the rest of the software can think in terms of immutable in, immutable out, and has all the safety of immutable software, of immutable objects. So in this case, because this mutable variable and this mutable thing doesn't escape the function, the rest of the software doesn't know if mutable or immutable states are being used here. I could completely change its implementation to an immutable one. The software wouldn't know. I can change it back. The software wouldn't know. So mutable states, in my opinion, like you can use it, but be careful with it. And if you do it, try not to have it escape function scope, because that's the point where the cognitive load becomes way higher than it can be.
Got it. Yep. Thank you.
And
Thank you.
Yeah. My understanding. Correct me if I'm wrong. My perspective towards Sunil's question is, Sunil, we as a programmer very familiar with writing mutable code, right? Setters and getters. Correct?
Right.
Sunil?
yeah,
Right. Correct.
yeah.
Okay. Actually, the setters and getters, when these were introduced, we used to develop UI applications in Java, Swing, and all those stuff. Early days of Java.
Right.
At that
Beans.
point in time, setters and getters were crucial part of our user development. At that point in time, the default choice of a language was mutability. But later, as the hardware accelerations, all these modern technologies came, people realized, particularly web application developers realized that immutability is the real strength. Immutability is supposed to be the default, and you can actually break and then go to mutability, not the reverse. That is the realization. That is the direction where now going with record, you get immutability by default, but the drawback is your programming perspective. That is, so far we have been comfortable with setters and getters, which will take some time. In fact, this was one of the question to the JDK development team. The answer to that question is that the person was so critical, the one who implemented it, he simply said, no, it is supposed to be done in this way. But again and again, in Java community, people are asking. T's answer was actually refreshing to me also, because of the community demand, I think now Java is coming up with a new structure where they are matching both the performance benefit of immutability as well as that syntactical thing. They are adding something new, which is a new thing for me also, because at that point in time, the team was entirely against going with that setters and getters again. That's not the direction that we should go.
Fully agree. This talk is a very, if you're struggling with that, this is a very good talk to watch. Simple Made Easy from Rich Hickey. Because he puts it in a completely different perspective. Since simple is something else than easy. Because easy is a easy versus hard, and simple is simple versus complex. So the thing is that if you know something, it's easy. If you don't know something, it's hard. So simple versus easy, easy versus hard, is very subjective. That's different from person to person. While immutable state is inherently simpler than immutable state. Mutable state by definition is complexer than immutable state. So that's an objective thing. You can't disagree with that because it is a fact. But it's also that if you can see in that way that this discussion is a easy versus hard thing, that just means if you start using it more and more and more, if you start learning it, it will become easy. So that's with a lot of things where people are like, oh, this is way too complex or something. Then you have to take a look, does that person mean it's actually more complex, or is it hard for that person? Because if it's hard for that person, that's something you can fix. That's just teachable, and then it will slowly become easy. Or is it actually more complex? Yeah, then it's wrong, because we should favor simple approaches. So this is a very, very good talk about that. This has really changed my view on software engineering.
Sure, I'll also go through this talk, definitely.
Murali, you have a question, right? You can unmute and speak. Yes, please go ahead.
Sure. Yeah, so my question was more on the sealed interface. So I have experience in Scala, so I knew sealed trait there. So do we get more than Scala in the Java 21 feature that along with this sealed interface? And another thing, so in Scala we define all these in one file, and generally in Java we will have one class in a file, right? So how do we put these sealed interface and records in one file or multiple files? And how that works?
That actually does it better than Scala. You can choose. Right now, I did something here that's not fully correct. I can omit this. If it's in the same file, I can just write it like this. if I want these things to be in different files, then you need the permits keyword. So with this, Visa card can be in a completely different file, a MasterCard can be in a completely different file. Or you can write it without this and then declare them in the same file. And that would also work.
Right.
So
thank you. Sorry, one more follow-up question. So like what I see nowadays, right? So in Java, so all the features that is there in the Kotlin or Scala, they are slowly adding it to Java.
Yeah.
So if we look into functional programming, so I just wanted to know your opinion. Is it good to still stick with Scala because that is much more powerful and gives more features in functional programming? So should developers stick to that or should start looking to Java side? Because I think still there are a lot of things that are not added to the Java even at this moment.
So basically, that's what this whole talk is about. That's about functional programming in Java. In a way, functional programming can be done in any language. It's mostly a way of thinking and a way of a certain approach to problems. And so therefore, yes, you can perfectly do functional programming in Java. That being said, language features do help with it. So Scala is way more powerful than Java, basically any other language on the JVM regarding to functional programming. So if you really just want to go heavy into that paradigm, Scala will help you more than Java. If you, however, are programming Java, the fact that you're not using Scala or Kotlin doesn't mean you can't apply all these principles. It's just things like everything is nullable by default in Java. So you kind of have to do what's the word? You kind of just have to make sure you don't abuse that. And you kind of have to assume other people don't abuse that. But given a few assumptions here and there, you can still do functional programming in Java. You can always do it better in Scala, but you can get not decently close in Java these days. The thing about Scala is that because it's so powerful, people tend to write things in 10 different ways because you can write it in 10 different ways, which means that you kind of have to know Scala quite well. And it took me, my first attempt to learn Scala, I couldn't get through it. Then I learned Kotlin, and then using that knowledge, I learned tried Scala again, and then I could get Scala. But Scala is not an easy language to get introduced to. I do think Scala is a beautiful language.
Yeah, I do, and I was. I mean, the only thing that I felt many times compilation is a bit slow compared to Java. That I felt. Otherwise, the features that we get in Scala is much better. But what I see now in Java, most of the useful features we are getting to the Java, and yeah, so I was looking into that, like whether I should explore more on what is coming in Java and try to learn that.
And we need people like you because you worked with sealed classes before and sealed interfaces. You know how to use those. And most Java engineers don't know that. So we need people like you with experience in this to teach the whole Java community and show people the power of using some types like this. So please share your knowledge with other people about Scala because it's relevant to Java people right now.
Yeah. So thanks a lot. Sorry, we took extra time from UTs, and thanks for the very useful session. It was very useful for every one of us.